Welcome to this session. This session we discuss the working rule for finding singularities of a function f of z. Majorly, there are three steps on how to find the three types of singularities. So step one, if you find the limit as z approaches a of a function f of z exists and is finite, then z equals to a is called a removable singularity point or a removable singular point. A removable singular point. For example, if we have the function f of z given by sine z over z at z equals to 0. You see, when you define the limit as z approaches 0 of this function f of z, we get limit as z approaches 0 of sine z over z, which is limit as z approaches 0. Now you write 1 over z into sine can be written as z minus z cubed over 3 factorial plus z power 5 over 5 factorial minus z power 7 over 7 factorial plus other several terms. Then this is the same as limit as z approaches 0. Multiply 1 over z by every term, so we have 1 minus z squared over 3 factorial plus z power 4 over 5 factorial minus z power 6 over 7 factorial plus other several terms. Then you see this will be 1. But you see f of 0 is undefined. But then since the limit exists, then we redefine f of 0 as limit as z approaches 0 of sine z over z, which is equals to 1, i.e. we let f of 0 to be 1. Then the function will be, so we'll have a removable singularity at the point z equals to 0, and then the aspect of the reasons why we are saying that removable is because we can redefine the function to do away with the singularity. So that is the first step, that whenever you define the limit as z approaches a of f of z and you get a finite value, then that is a removable singular point. 2, so if the limit as z approaches a of f of z does not exist, then z equals to a is an essential singular point. So when the limit of the function as z approaches a is the limit doesn't exist, then that defines an essential point. So e.g., if we have the function f of z given by e raised to 1 over z at the point z equals to 0. So you see f of z equals to e raised to 1 over z can be written as a series 1 2 factorial z squared plus 1 over 3 factorial z power 3 plus other several terms. You see limit as z approaches 0 of e raised to 1 over z will be limit as z approaches 0 of this series 1 plus 1 over z plus 1 over 2 factorial z squared plus 1 over 3 factorial z power 3 plus other several terms. Because we have z's in the denominators from this second term up to infinity, then this limit does not exist. Because we'll be dividing by 0 in each of the term from the second to the last, to the terms to infinity. And then number 3, or what we call step 3, if the limit as z approaches a of the function f of z exists, not really the limit is infinite. If this limit of the function is infinite, then the function f of z has a pole at z equals to a. The order of the pole is the same as the number of negative power terms in the series expansion of the function f of z. So that's how we define the 3 types of singularities. So we'll do examples to illustrate how each of these singularities are obtained for different problems. Thank you.